Hello, my name is Peter Pilgrim. I am the founder and organizer of the JavaWUG users group in the UK. I presented a piece called Rearchitecting Legacy Enterprise Applications Using the Spring Framework. This presentation took place on Thursday, the 13th of July 2006 at Oracle's City of London offices. Enjoy this one, especially from me. So my presentation is Rearchitecting Legacy J2EE Applications for the Spring Framework. And the idea I had for this slide was to help out Emmanuel a little bit, just in case, but that's okay. So moving swiftly ahead, I had the idea for this presentation about a year ago, but didn't have a Spring project actually to use it with. But I saw lots of opportunities when I worked at the unnamed investment bank for the last one I worked for using some inversion of control, and it would be really good for the architecture of the application. So in that time I moved from one project into a new project, and that had like the real, I suppose, meat on it, and it was a kind of a new project. They had EJBs already written for him, and they were using JMS, they were using WebLogic, and the way that some of the internal libraries were written, I felt could really lend a hand with the Spring Framework. So the Spring Framework, I assume there aren't many people who have used Spring, apart from Duncan, who knows more about it than most of you, is actually an inversion of control container. And what that means, in effect, it's like a lightweight container that works with plain old Java objects. And what you can do is, before where you used a lot of singletons in Java, which were basically static classes, and what you would do is have all these static dependencies polluting your service beans. And what Spring and other lightweight containers do, they turn it on its head. Instead of you in your business logic or your service beans using directly calling an API or a framework to get a resource, these resources are injected into your service objects. And it takes a bit of a while to understand that, but trust me, it's a real cool thing, especially for agile development and test-driven development, because it means that you've pulled away those resources from your business layer. It means you can actually test them outside of a WebLogic container, for example, or any sort of container. It makes you more productive. So anyway, I would say Spring is one of the most cleverest toolkits out there. It really does help you with Java Enterprise Edition development. You really don't want to be coding JMS from the root level now that you've got Spring, because you don't have to do all this catching of say a naming exception when the JNI fails, or when you're publishing a message and a transaction fails. Spring takes that and transforms your checked exceptions, which is all throughout the Java or J2EE spec, into unchecked exceptions, which means that you don't have to worry about that and you shouldn't be worrying about that, because if something fails, you should let it fail, report it, put out a log, and don't catch it again. It fails, an engineer in production will fix it, or it will come back to you as a stack trace. what you shouldn't be doing is catching, say, JDBC exceptions and trying to do something clever. And what normally happens is something will go wrong and you forget to close a resource like a database in your try and catch logic. You forget to something, you acquire a resource and just leave it open because you haven't closed it. So, if you know, I've started a new contract today and I'm going through exactly the same process, and that gave me the idea for the talk. So the kind of thing you'll do is have an induction, you get to know your colleagues, have a quick meet-up, get to start understanding that high-level architecture and the business. What are they trying to do with J2EE? And that's what it is really. It is an enterprise specification. And as I said, you don't really want to be coding under low levels. If you find that is, then there's something wrong in these days with something like the Spring Framework that abstracts so many things that you could find. Typically, EJBs, JMS and JDBC are the things that you would want to abstract on and develop. So on day 2, well for me today, it was trying to understand what kind of architecture you have, and then you can have a simple web tier application which would be Tomcat Resin, one web container running somewhere. And then you, on the other hand, you have your application server architectures. Really, I've written out architectures there. Actually, they are application stroke infrastructures. And you can have one application server that runs one single application, or multiple applications that running on multiple application servers. So it can get really complex, especially for big enterprises, and depending on what they want to do. So that one is your typical Tomcat, what you and I would do if you're doing a shared web host with, say, Positive Internet or anybody else. And that's what you'll get, and especially if you're doing an application at home. You might be tempted by an application server, and small businesses would probably do something like that on some kind of managed server at their local ISP provider. I should really go back there, because if you haven't seen application servers before, what I've tried to explain here is all the containers that are going on, and then you have your support with all your services, and that's what application servers give you. Your EJB support, your transactional support, your name services, and obviously your data source support. And obviously these architectures are going to be database driven. When you get into bigger businesses, then you might have more databases. You're definitely thinking about splitting up your core business use case into something like payroll or sales, so you get 2 enterprise applications as well. And then it can go on and on with multiple application servers and the application. Obviously, these applications are going to be talking to each other using XML or directly through the database or through JMS. And so basically that is what the JAVAWUG is really all about. It's about helping the lowest person on the ground with a simple web application to big corporates who really need that load balancing, the clustering. They really need mission critical software, and this is, I suppose, an investment banking architecture. This is really just a few items. This could be like 50 boxes if you were to take it, if they really were to go overboard in their block diagram architecture. And you have databases everywhere, Sybase, Oracle, the big two, and you have different processes and legacy databases and legacy applications. So Spring can help us with all of this. And so on the next day, you might be still trying to understand what is it that they actually want using Spring. And you've got to go through the normal rigmarole of understanding all the TLAs, the three-letter acronyms, OBDOBs, or whatever they are talking about in their business, understanding that language. And that's something, that's the slide that was unbalanced, so lost. And then you might, once you understand their use cases and their businesses, or what they want, then you might have a chance to, say, propose some open source technologies, if you haven't had a chance before, like Spring or Hibernate, or WebRep or Java Server Faces. And so, supposing you had the chance to use Spring, and I'm saying on this slide, well, really that this is an enterprise that's using EJBs, the first thing I would say is that if you can look at their enterprise Java beans that they've written, and keep your fingers crossed that they're not entity beans but session beans, because they can be refactored. And if you're going to use Spring, you would most likely use the stateless, abstract stateless session bean. An abstract stateless session bean really delegates to a plain old Java object. So if you have an old-fashioned EJB2X bean, really you gut it, you refactor it and create a service bean, which is your POJO. Give it an interface, and then with your gutted EJB, your session EJB, now also implements your service interface. So, and then in effect, that's what you're doing. You're creating Spring enhanced EJBs that allow you to test outside the container, because basically what you've got there is a plain old Java object which doesn't need an application server anymore. So you can run your unit tests with your service beans, provided you mocked all the resources, everything, other dependencies with Spring inside Eclipse or NetBeans, and you don't have to be deploying to a WebLogic or Oracle server anymore. And that really speeds up production and of your code, of course. I said there, I've never seen a distributed entity Java bean, but I have seen at my last client a Java connector architecture thing, which was talking to a mainframe, and where I understand what I've written is understand the use case. I mean, you could start working on that just to get Spring working on something like that, but it might be better if you've got something that talks to a mainframe. Maybe someone's written a C+ service and you can talk to it using a web service. Well, Spring could help you do that, but then you really have to understand that business use case. Why have they got distributed entity beans? It's very weird that I've seen anybody using that sort of technology, unless it's very ancient EJB1 stuff. And if you're lucky enough to use Java 5, then you would know, Java EE5, you would know that you can do use the new Hibernate or TopLink or the Java Persistent API to do that sort of thing. Communicate with a back-end database. And Spring makes it a lot easier to work with JDBC, traditional JDBC data sources, and other sorts of data sources. And one of the things that I found with some of the banks is that they didn't use entity EJBs because they had massive problems with them. And so what you've got is they use their own data access objects, which, you know, did this traditional JDBC connections and try-catch blocks. And one of the things that was refactored, ones that I had a look at, was one of my tasks was obviously to write new data access objects. When I got the chance, I'm going to use Spring because JDBC templates make it a hell of a lot easier to write that sort of JDBC interaction with the database. And the whole point of it, using the templates, is you no longer have to use try-catch blocks. You can use anonymous classes, or you could use specialized template classes to talk to your database component using queries or even stored procedures if you want. But the whole point of it is that it made writing data access objects, the create, retrieve, update and delete methods so easy. One caveat with that, with the old legacy data access objects, is that they depended on a Java SQL connection. There's one problem with a connection, is that it has to be created and then be used. So when I got the chance, I refactored the data. I don't know how, I can't remember how I did it now, but I said, look, this is it. We've got to use data sources, because what does a data source provide? It has data source dot get connection. And so by pushing data sources, then you can inject the data source into your data access object, and then it can get the connection and close the connection and retrieve all the information. Using the connections was no good because you just had to connect them. You had to know which database you were connecting to, and it obviously is a lot easier with a data source. One of the things that Spring provides is a couple of data source providers, so you can get your data source from JNDI like you do in an application server, or you can connect to it using a traditional traditional JDBC provider, which you need to have the JDBC URL and username and a password. It's not coming from the application server as a JNDI resource. So, one of the things in enterprise applications is publishing of JMS, and I've seen some interfaces where almost every place I've worked, someone's written their own internal abstraction to publish to JMS. I mean, if you see that, you can use it, and you still, if it's correctly written, you won't have to deal with catching JMS or JNDI or naming exceptions. Spring makes that a lot easier to publish to a JMS queue. The one thing that's not in here is that Spring 2 also now supports asynchronous JMS, and that means that even if you're not using an application server, you can use a Spring abstraction to receive messages without using application server. We are using application servers here. Spring makes it a lot easier to wire up your publisher to your JMS template, and that is a lot easier. You end up writing less code. All the code that I actually wrote from my last client shrunk into piecemeal. So Spring does help you with the agile process, and I would say it lends a very good hand to it, because one of the things with at least banks around here, there's a couple that are doing actual peer programming, which I think is the French bank, but most of the time they're not doing pure agile, because it's a difficult thing for them to do, obviously, because they need seats on chairs, and of their time limits and their constraints, you need to get your head around. It's so new. So what I found they actually do is iterative development, which means it's more like Scrum, where it's all buffered requirements, and they have a meeting every month or every 2 weeks or every day, and it's not quite agile development where you're really doing XP. Right, I'm going to write this test class first at a unit test, and then I'm going to code. You still get the functional documents, you get your project initiation documents, and it has to be signed off. That was the case in point today. They are getting better, and one of the things, because I'm not a manager or a head Hegian, that obviously helped. Look, I could say to the manager, look, I've written these unit tests with Spring, it's injecting all my resources, I've used this, that and the other, I can show that my unit tests work. So Spring gets you there, especially if you can show that by just pushing a button on Eclipse, like you just push the debug button and there you go, unit test fires off, and it's a simulation of what you expect to run when you build your Maven or Ant EAR and then deploy it into WebLogic or whatever. But the interesting thing I think with Spring, it's a little bit ahead of the wave. I actually think with that we're going to have pair programming, not as two people at a keyboard, but more virtual, like peer-to-peer. And some of the IDEs have come out. I know Borland has done something like that. And NetBeans are doing a lot of collaboration stuff. So it is coming, and the tools are starting to appear. So with that, because Spring is an ILC container and you inject dependencies into your plain old Java objects, it makes it easier for test-driven development. And there are a number of things that can help, like mock EJBs, mock runner, where you can mock a JMS stack or a JDBC, well, not a JDBC, you mock an EJB, and you can really test these things outside the container. Especially, I love the fact that you can test EJBs at the container by just following this model. In fact, the whole idea of abstracting an interface and an implementation comes back from my C++ days, or the old envelope and letter classes that you used to have. And the fact that you can do that, that you can inject things, makes it easier for you. The one thing I would not do is, I've seen people do, is try and mock a database. They would mock something like the whole of Oracle in Apache Derby, which is really stupid. Of course you can't mock PL SQL procedures. It's better when you are dealing with corporates to look, give me a staging test database that I can run my unit tests again and have expected data and actual data, make a cross correlation. If the data's wrong, the JUnit test fails, and that's that. So Spring is really going to change things. One of the things that I would say is that we've got a new specification for JAVAWUG EE5. I believe that entity beans will disappear, the old ones. I can't see a reason for distributed data role sets. Not for any reason. Can't see it. And the JPA may run up against some steam, and that I don't know. There are lots of people in, well, financial institutions in the cities that still want to use Oracle's PLSQL as their backend. But I believe a JPA can still call native SQL as stored procedures. It's when you do quirky stuff like reference cursors that it may break, because what a reference cursor is, and I know that from my Deutsche days, is they perhaps use like a cursor that is a cursor onto a result set, and that might break your Hibernate or your top link unless there's specific support, unless you get into Hibernate and code some hack or something. I believe the only one is a big name application server, probably is JBoss at the moment. I don't know if Oracle have brought out a certified JEE5 server yet. Probably not. WebLogic 9.2 is still 1.4. But it's definitely coming, and I think it will be with us at least by Christmas. The point is that Spring still makes it easier by solving all the boilerplate issues that you will need to use with the Java EE. It still will be low level, and if you're like me, you need to get a contract, and you need to get some code out in a week, and I don't want to be mucking about with try and catch. And I would rather use Spring to help me in the architectural side of it, injecting my resources, making things easier by making everything a plain old Java object so it can be instantiated easy, and wiring all that functionality in. And the other thing I would say about Java EE, I've not tried it yet, but by using that annotation you can make any Pojo method, I believe, a web service. And using EE5, I believe there was some talk of making some kind of JMX server or something available on Mustang, but I think the wires have been crossed in my head. It probably won't happen because you need a web service provider. So, the bad thing I would say about Spring is that you're getting back to the old XML hell, where you have lots of application contexts. I've even seen an application context used to make a rules engine a dummy rules engine where someone's like written a set of beans that follow the command pattern or the chain of responsibility pattern. And what they've done, every command, say it might be like save state, create, like maybe something like filter account, merge accounts, and they've put them into a Spring application context and made it a really clever, I would never thought of that sort of configuration for a simple state machine. And they've got all sorts of like, they've written like another Pojo for like holding like all these commands. Sort of like almost common chains. I don't know, how am I doing for time? I've got a couple of minutes now. And so one of the things that Spring does, if you're using EJBs, is that you can get into a problem of using application contexts all over your J2EE or JAVAWUG application, and it's sometimes good to manage those by using the contacts singleton bean factory locator, which helps you you can make Spring application contexts nestable or inheritable, not nestable. You can do it nestable as well, so that you've got one child application context that also is connected to a parent application context. So if you're looking up a bean in one, like foo, and if it doesn't find it in the child, it actually goes into the parent context and then retrieves that bean for you and creates it, or creates or retrieves it. So that's quite useful. And this, because of the way Spring uses EJBs, it's sometimes very useful if you know your EJB spec, you can create all these EJBs session beans and load them, and you can create 100 session beans, and they could all each have their own application context, and that would be a waste of resources. And sometimes you need to access shared definitions. So that is one recommendation. The other way is to code it yourself, and I sort of did this. I wrote myself a lightweight application context loader that worked off WebLogic, because WebLogic has its own API, of course, and you can put in like a WebLogic application context that you have a startup class, and that could be the way where you load your core resources to do whatever you want in your application server. And then I wrote my own singleton to make this available. The other thing that I found, that sometimes I needed a way for the administrators to inject resources between something like UAT and production, and I wanted to keep the same Spring application context file. So what you can do is just like, you can have placeholders. You can use like $signs, like, and to get system resources. For example, there's a system bean resource placeholder configurator, so that you can inject like JDBC URL or password into your bean without having to specify it inside your application context. So I did a similar sort of thing for the last year client, and that was a good way of injecting foreign resources. I'm unsure whether with the application servers as they are now, whether you should use the AOP, the Spring transaction demarcation, unless you're thinking of writing an application that runs inside or outside the application server, which is a very strange thing, but I think there might be a use case. I just haven't found it yet. And I would say if you're going to do that, you might want to look into the AOP side of it. But the AOP side is used in Spring anyway, so if you're going to use that transaction management, you can get the proxy bean factory, which is we use CJlib or actually the old proxy interface for JDBC 1.3. So if you ever come up with these projects and get into Spring enhanced EJBs, it's a good idea to have service interfaces and service beans. Yeah, applications will definitely still have value out there long after JAVAWUG 5. Really make use of the templates, the JDBC and the naming templates and the JMS templates, because they really do help and aid you. You make it easier to code. And keep on rocking with the agile development. And that's now a statement. If you can read that. So, thank you very much. Any questions?